This is how we go about solving these problems where we know we have a quadratic, we're missing one piece of information, and we want to find something. Like we want to make sure that it's factorable or that it has no x-intercepts or something like that. So, thinking about that for this one, let's just say that again, Mr. Devandy spilled his coffee or whatever is the question, and he wants this quadratic though to have no x-intercepts. So thinking about it that way, if it has no x-intercepts, that means that zeros have to have an imaginary component to it. In other words, there's going to have to be some I in the answer. Because if there's not an I in the answer, we can find those spots on the x-axis. So no x-intercepts means there's an I. And the only time there's going to be an I is when we're going square root of a negative number, like -5 or something like that. So with that in mind, we have to end up going square root of a negative to have no x-intercepts. If I knew A, B, and C, I could run it through the quadratic formula, and that would give me my answers. I don't know C, but I know A and B. But as I run it through the quadratic formula, this part in here has to end up being negative. This is the discriminant. This right here would have to be negative to give me an I, which means I have no x-intercepts. So basically, what I'm concerned about in these types of questions is b squared minus 4 times a times c. So if I'm looking for no x-intercepts, that means that this is negative. In other words, it's less than 0. So let me plug in some values. Let's see, b is -6, so I have -6 squared minus 4. I know a is 2 times 2 times c. The question is, when is that less than 0? So -6 squared is 36. -4 times 2 is -8c. When is that less than 0? So basically, well, when this is going to be less than 0 is when this 8c is bigger than 36. So if 8c is larger than 36, this whole thing will end up being negative because it's something minus something bigger than it. So divide both sides by 8. 36 divided by 8. Sorry, that's supposed to be a greater than sign. I'm just going to check. I think that 36 divided by 8 is 4.5. Oops. So as long as c is any value larger than 4.5, this will not have any x-intercepts. That's how I can use that discriminant to figure it out. All right, let's keep this same situation going on then, and let's do another situation. I'm just going to erase all this. Excuse me. So instead of no x-intercepts, let's figure out when this thing would be factorable. Yeah, that's a good one. Whoops, sorry about that. So if it's factorable, that means I can write it like, x plus something times x plus something. The only time that this is going to end up being factorable, the only times, is when I run it through quadratic formula, but square root is totally used up. In other words, like I go like the square root of 100, and then that's just plus or minus 10. So then I get those fraction answers. So I need this b squared minus 4ac. It's factorable when that ends up being a perfect square. So I could basically set this equal to any perfect square, and that will give me my c values. Again, I know a, I know b, so let me plug those in. -6 squared minus 4 times a times c. And I don't know, I'll try... any perfect square. I'll just try 100 and see what happens. So 36 minus 8c equals 100. So subtract 36 from both sides. So then I get negative 8c equals negative 64. Nope, positive 64. Divide by negative 8. C equals negative 8. So I know when c equals negative 8, this thing would be factorable. So I could put any perfect square here. I won't always get a whole number, but I could put in 25, or I could put in 16, or I could put in 0, or 4, and solve them. And whatever I get, those are possible c values that would work. Let me do another example. So how about if I only wanted to get 1 0? So if you think about that quadratic formula, negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. I'll only get 1 0 when this thing is a 0, because then it would be negative b plus or minus 0. So 1 0 will happen when b squared minus 4ac is equal to 0. That would be a graph that comes down and only just touches it exactly 1 0. So let me plug in my a value and my b value. So b is 8. 8 squared minus 4 times a is 4 times c equals 0. 8 squared is 64. 4 times 4 is 16. So 64 minus 16c is equal to 0. That means that 64 is equal to 16c. So I could divide both sides by 16. And that means that c must equal 4. So when I plug in 4, this thing will end up being a 0, which makes it so I only have 1 0 in the whole thing.